There are 33,000 pounds of stored tension running through the slab beneath your feet right now. You cannot see it. The concrete covers it completely. And the contractor who added your second bathroom last year may not have checked where it was before he drilled. A cut post-tension tendon does not break. It detonates. A post-tension slab is reinforced with high-strength steel cables, tendons, tensioned after the concrete cures. Each tendon is a 7-wire steel strand, half an inch in diameter, inside a plastic, grease-filled sheath. They run through the slab in a grid, 48 to 60 inches on center. After the concrete reaches 75% of its design strength, 3 to 4 days after the pour, hydraulic jacks tension each tendon to 33,000 pounds at the slab edge. The tail is cut. The pocket is patched. The slab looks identical to any other concrete floor. The tension is locked in permanently. Florida builds post-tension slabs because of its soil. Sandy, low-bearing capacity soil settles, and not uniformly. Differential settlement cracks a conventional rebar slab across its unsupported span. A post-tension slab responds differently. The tensioning puts the entire slab in compression. When soil beneath one section settles, the slab bridges the void rather than cracking across it. In Florida's soil conditions, the PT slab is not a premium option. It is the structural response to a ground that moves. The energy stored in a tensioned tendon at 33,000 pounds releases in milliseconds when severed. The cable recoils at hundreds of feet per second. Documented incidents show cut tendons penetrating walls, embedding in structural members across the room, and causing fatal injuries to workers who were not standing directly over the cut. The danger zone is not the point of the cut. It is the entire unpredictable trajectory of the recoiling cable. Ground-penetrating radar must be performed before any penetration of a post-tension slab. GPR images the embedded steel, tendons located, safe coring points identified, documentation provided before the drill goes in. For permitted work, this documentation is required. For unpermitted work, skipping it creates the same release event. The permit status does not change what 33,000 pounds does when it releases. FBC R506.2.4 requires PT slab design by a licensed structural engineer. The PTI DC80.3 standard governs materials, anchorage zones, and stressing documentation. Stressing records, force per tendon, elongation, date, must be maintained with the structural record for the life of the building. PT slabs require special inspection under Florida Building Code. The special inspector verifies tendon placement and cover before the pour, then documents stressing force and elongation per tendon after. A slab without a special inspection record has no verified basis for the claim that tension was applied correctly. Identifying a PT slab before renovation begins is possible at the slab edge. Pocket patches, small square patches, 3 to 4 inches on a side, mark where tendon tails were cut and pockets filled after stressing. Visible at exposed edges in garages and at the exterior foundation perimeter. If covered, the structural engineer's drawings in the permit file specify the slab type. The renovation triggers are specific. Bathroom drain requires coring. Electrical conduit requires penetrating. Pool construction at the building edge may require cutting in. HVAC and plumbing, core drilling. Every case, same sequence. GPR scan, tendon locations mapped, penetration point confirmed clear, then the drill goes in. A contractor who skips the scan is not saving time. He is creating a release event with no predictable outcome. The cable has been under 33,000 pounds of tension since the day the slab was stressed. It will stay there until something cuts it. Make sure that something is not an uninformed drill. If you're planning any renovation that involves penetrating a Florida slab, share this before the contractor arrives. Subscribe for more Florida building code in plain language.